Hello, this is simply about networking protocols, and today I'll tell you about MPLS. Standard that describes basic MPLS features is RFC 3031. Then you should use another standards that clarify this one, or many vendors had MPLS-like protocols before MPLS or some modifications of MPLS protocol. So you should carefully read documentation and specifications from your networking device vendor that describes how actually MPLS works from this vendor. In this video, I'll tell you about why do we have a need for MPLS and its basic benefits, MPLS basic definitions, and briefly describe operations, and device roles in MPLS domain. So, what is the need of MPLS at all? We have switching, we have routing. What else do we need? Pretty simple. Imagine we have some network segment where we have multiple interconnections, multiple interfaces within this segment, but out of this segment we have pretty limited amount of physical interfaces, physical ports, and limited amount of interfaces that pointing out. Then, to process a packet, a frame, for example using routing, we need to get to the FIB table, that is routing table, and by destination IP select next interface, next hop that we will send this traffic for. Then by next hop IP we need to go to RP table and get MAC of the next hop. Then by MAC table, by this MAC we need to go to FDB table and select actual interface that this packet will egress, then send this packet, and don't forget we need to modify Ethernet header totally. Very time consuming, very resource consuming, many operations to perform for each packet that goes by this route, right? And each packet means that, for example, we have subnets, and in this subnet we have 10 devices. For each of these devices, each packet will be processed in this way. Well, very resource consuming. But actually, we have, in this example, we have only 3 physical ports to get out, right? More than that, in this segment, we have eventually 6 boundary ports that we can use. And for each packet, for each frame, we have only 5 possible destination ports in this, because one is actually ingress port, right? So we have very limited end of the routes for this segment. And on each stage we should repeat all those terrible amount of actions, right? No. Here MPLS gets in. So main idea is, what if for a frame we will add a label that will point us to which physical interface it should egress our segment, right? Then we need to perform only one lookup per label on each device, not all these terrible set of lookups. And then this packet successfully gets to the egress of the domain of the network segment that is for this label domain. For different frame that destined to different port, we can use same label or different label, and it will get to the actual physical egress port from this segment, from this label domain. And this is actually MPLS domain, where we can use multiple labels to reduce amount of operations we perform with each frame on each stage of processing. First basic definition for MPLS is forwarding equivalent class. Each ingress frame has some fields, and those fields being processed on each stage of the processing, pointing out to some egress interface. So we have a frame that needs to get to some destination, and this is actually forwarding equivalent class. In this case, for example, for routing we have destination IP that on each device pointing out to specific IP on specific network, pointing out to specific device in this network. So we need to calculate the path for this stream. But if we pointing out, for example, for each frame that goes to network B, we don't care about actual device that needs to receive this frame, because final decision will be done somewhere in the network B or step before network B. So all frames that go into network B, we can claim it as one single forwarding equivalent class and have a label to it, added to it, that will point out that we need to reach this specific interface. So also we can define forwarding equivalent class based not only on destination interface but also on ingress interface, on source interface, where we receive this traffic. More than that, we can use meaning or value of each field in our frame to define FAC mapping criteria on our device. So standard claims that any field in the frame or any combination of the field in the frame can be a source for calculation of mapping criteria to FAC. In this case, you need carefully read documentation of your specific vendor device, where possible combinations could be somehow limited or specified. So FAC is a frame that that is classified somehow, and all frames in the specific FAC will receive single label. Next important definition is related to the route, to the destination of the traffic. Each pair of the devices within MPLS domain is upstream-downstream device. Upstream-downstream claims from which device frame will be transmitted to which device. Frames transmit from upstream device to downstream device. So traffic or frame that goes to the network C on this particular hop from upstream blue goes to downstream green. If frame goes vice versa in opposite direction, it will go from upstream blue to downstream green. Why this important? This is important because label is defined between each pair of the devices for each FAC, and downstream device defines the label. So in this pair, downstream device tells for FAC 1 label should be 1, for FAC 2 label should be 2, for FAC 3 label should be 3. In this pair, for same FAC 1, this device can define different label, because label 1, for example, will be already used somewhere. So again, basic MPLS operations: destination matters. We always need to keep in mind where from frame goes where to. On this particular example, we have a frame that we need to send somewhere upwards. For example, frame is generated by some device that is not in MPLS domain. Then, first step is always to get an initial label classification. This is what happens when we assigning frame to a flag. We assigning initial label. Then an HLFE table appears, next hop label forwarding equivalence. In this case, we are asking for table based on the first label, and this table provides us information where to forward this frame and which label to edit. Here, again, standard allows two possible actions. Well, standard describes many actions related to labels, but they are not basic. Basically, we have two actions. Stacking labels, it means that new label is added to the stack of labels, or override labels. New label will override old label. Check with your vendor what happens on your devices. And in scope of that, as you understood, we have three basic roles of the devices related to MPLS. First one is MPLS ingress node. This is node that is boundary between MPLS domain, MPLS network, and non-MPLS network. In non-MPLS network, some other mechanism is used to process data frames. As you remember from the video related to the basics of the data processing and transmitting, this can be switching, routing, whatever. But MPLS ingress node maps initially ingress frames, so maps initially equals to performs FAC mapping, forwarding equivalence mapping, or forwarding equivalence classification. This is the same. Then appears an HLFE table where we initially reading information and then sending this labeled somehow stacking or overwritten packet to MPLS network, where standard MPLS node is working. We're receiving labeled frame, checking an HLFE table, and forwarding according to the information that is written in this, stored in this NHLFE table. Next, with new label. And MPLS egress node, where this is the node device that stands on the egress from MPLS domain or MPLS aware network, where we removing label and preparing the frame to be processed by the next hop according to the transport protocol that is used by this next hop, for example, switching or routing or whatever it used. That simple in basic MPLS is. Thank you. Have a great day.